Hey, 8th grade. So our learning target today is I can find the point of intersection between two equations using their equations. So we talked about point of intersection, or where they hit each other. In a graph is super easy to see where the two lines intersect. In the table, we're looking for the same x, y values in both tables, same place at the same time. So an equation, what we're going to do with the equation work is we're going to set them equal to each other. So we're going to say, when does this first equation, we'll call it y1, equal this second equation we're going to call y2. So we're going to go ahead and say, when does y1 equal y2? Now this is going to turn into the hand method. As I start to solve this, I'm going to eliminate the y values, and I'm going to substitute in 2x plus 1 in for y1. Notice I dropped off the y values. In for the y2 value, I'm going to substitute in negative 2x plus 9 in for the y2 value. So here we go. We have a multi-step equation with a variable on both sides. Smallest variable goes. My smallest variable right now is this negative 2x. My choices are positive 2x or negative 2x. Negative 2x is the smallest. I'm going to do the opposite sign, which is to add 2x, copy, paste. Working left to right, left to right. We get 4x plus 1 equals 9. Hand method kicks in. I'm going to subtract 1, copy, paste. I'm totally running out of room here. I'm going to resolve the rest of this up here. 4x equals 9 minus 1 on the right-hand side becomes 8. My job is to get the variable x totally alone. So to do that, I'm going to divide by 4, copy, paste. The x value then is equal to 8 divided by 4. My x value is equal to 2. I'm looking for the point of intersection, so I'm looking for the x and the y that makes that true. In order to do that, I'm going to take that x of 2 and I need to substitute it in here and here. I really only have to substitute it in one time, but I'm going to substitute it in both times to make sure that my answer is correct. So we have 2 times 2 plus 1. That's 2 times 2 plus 1 is 5. So I would say that my y is equal to 5. I'm going to confirm that in this equation. Negative 2 times 2 plus 9. Negative 2 times 2 is negative 4 plus 9 is also 5. So my point of intersection in this problem over here is 4, 5. That's through the equation work. Now we're going to fast graph these just to confirm that everything is good to go. So when I fast graph them, I'm going to start with the y-intercept of 1. On that y-axis, I have a y-intercept of 1. So here's my y-axis. Y-intercept is up here at 1. I'm going to run my slope there. My slope is 2, which really is 2 over 1. So 2 over 1 becomes rise 2, run 1. So from there, I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Keep going. Rise 2, run 1. So I have this graph here of my equation y equals 2x plus 1. Now I have this other graph, y equals negative 2x plus 9. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And it has a slope of negative 2, which really means down 2, right 1. So we have down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So we end up having a point of intersection, or a POI, right here. And our POI is at 2, 5, which is exactly what we said it was supposed to be. I'm not really sure why I wrote 4 here. My fault. This should have been a 2, 5, because x was 2, not 4. My mistake on that. So in our equation work, we definitely had a 2, 5. We solved. We had an x of 2. We had an x of 2 here. We substitute in, and we got a y of 5. So we had a 2, 5 as our POI in the equations. We also had it in our graph. I know it's kind of a mess over here. Sorry about that. I'm trying to write with this tablet pen, and it's not as easy to do as it is on a regular smartboard. So let's talk about what our steps are for solving. Our steps for solving in step 1 is this pen is giving me a hard time. We are going to ignore the y's and set the equations equal to each other like we just got done doing. Steps 2 through 6 or 2 through 5 are the same that we've been doing all year long. Stop, chop, chop, combine like terms, move the smallest variable, and so on. And then step 6, of course, is to plug back in and check. Plug back in, get that y, and then check to make sure everything's good. So plug back in to get y. Go ahead and fill that out. Okay, so finding the point of intersection with equations. I think you'll like this, especially those of you that like the hand method. It's a lot easier than setting up a graph looking for the point of intersection. So we have the first equation equal to the second equation. So we want to know, when does y1 equal y2? When do they equal each other? The y1 value is equal to 2x plus 1. The y2 value is equal to negative 2x plus 9. Solving using the hand method, the smallest variable part moves first. So we're going to add 2x. Now, we already solved this once above. We're just going to confirm it one more time down below here. Same problem we just solved up above. So working left to right, 2x plus 2x is 4x. If I haven't used it, drag it down. On the right-hand side, negative 2x plus 2x was 0. If I haven't used it, drag it down. It is the exact same work that I did up here. We're solving it one more time. I do not want you to look up above to see what we did up above. Hand method kicks in. I'm going to subtract 1, copy, paste. And then what we did up above is that if I haven't used it, I drag it down. So we get 4x equals 8. Then, of course, we want to get the x alone. This is a multiplication problem. To get x alone, I divide by 4, copy, paste. So we get x equals 2. That's the x value. So we know the x is equal to 2. To get the y value then, we're going to go ahead and plug in here and here. So we end up getting y equals 2 times 2 plus 1. That's 4 plus 1. The y is equal to 5. Y equals 5. Now we can confirm that in the bottom equation, negative 2 times 2 plus 9. So negative 2 times 2 plus 9, does that equal 5? It does. So my POI, as we've said, is 2, 5. I'm really sorry about my work there. It's just really hard to write with this pen. So 2, 5. We've already confirmed that twice now on the same page. Example 2 now. Brand new problem. Example 2, here's our steps. Ignore the y, set them equal to each other. These steps are all the same. And then we plug back in to find the y value. So for example 2, here we go. We have y1. When does y1 equal y2? So when does the y1 equation equal the y2 equation? The y1 equation is 4x minus 12. When does that equal? The y2 equation is 2 multiplied by x minus 4x. Working left to right now. On the left-hand side, I'm going to stop, chop, chop that, and that's really all I can do. I cannot combine those like terms because 4 has an x in it, and negative 12 does not. On the right-hand side, you could combine like terms inside that parenthesis. I'm not going to do that. I'm just going to kill the parenthesis using distributive property. I do have a lonely variable, and I am going to stop, chop, chop. So I'm going to kind of take the long route on this. I'm going to distribute, which is 2, reattach the variable x. Pull down sign, distribute again, which is 2 times negative 4. There's a triangle problem there. Positive 2 times negative 4 is negative 8. Reattach the variable x. Working left to right, then we get 4x plus negative 12 equals 2x plus negative 8x. Solving them. On the right-hand side, we have to combine like terms. We have 2x's and negative 8x's. Think about that like a bank problem. We have $2 in the bank, and we're trying to take 8 out. If we have 2 in the bank, can we take 8 out? Answer is no. If we have 2 in the bank, we can take 2 out. We cannot take 8 out. So we're short $6. Reattach the variable x. On the left-hand side, if I haven't used it, I drag it down. Now, working left to right. What we have going on here is we have a variable on both sides. Smallest variable part, we move first. So I'm going to move the negative 6x first, which gets a little bit complicated. The opposite of negative 6x is to add 6x, copy, paste. That might freak you out a little bit because we just lost the whole right side of that equation. 4x plus 6x is 10x. If I haven't used it, I drag it down. In the right-hand side, I end up with a 0, which is just fine. We will go ahead and keep going hand method on this. Opposite of negative 12, I add 12, copy, paste. Working left to right, if I haven't used it, drag it down. And we get 12. So it's kind of weird what happens on the right-hand side. Notice how that comes out to be a 0. That freaks kids out sometimes. Multiplication here, to undo that, I divide, copy, paste. My x value is equal to 12. Divide by 10. Everybody should be typing 12 divided by 10 in your calculator is 1.2. That's the x value. We're looking for the point of intersection, though. So we know the x value is 1.2. We're wondering about what is the y value. So we're going to take that 1.2 and we have to substitute it back in here as well as here. I'm going to substitute in the top. Now, you don't have to substitute into both of them. you do have to do into 1 to get the y value. If you substitute back into both of them, it just confirms that the answer is correct. So we would say 4 multiplied by 1.2, putting it in for x, plus negative 12. Go ahead and type that in your calculator. So what I want you to type in your calculator right now is when we substitute 1.2 in for x, we'd have 4 times 1.2 plus negative 12 and find out what we get. Everybody type in that in right now. When you solve that, you should be getting an output or a y value of negative 7.2. So this would be my POI, 1.2 for the x and negative 7.2 for the y value. Okay, so our last problem of the day, example 3, top of the next page. In example 3, you know the new step for today is step number 1. We ignore the y's and set the equations equal to each other. Steps 2 through 5 are the exact same that we've always done. And step 6 is a little bit new as well, so that we can find the y value. So first things we need to do is we need to identify the two equations. We have two equations here. We have equation number 1. We're going to set that equal to equation number 2. So we want to know, when does equation 1 equal equation 2? When we do that, we ignore the y's and we set them equal to each other. Equation 1 has this as its value, 3 multiplied by 4x plus 1. Equation 2 has this as its value, negative 2 multiplied by 3 minus x. As I start to solve then, I use the distributive property to kill the parenthesis. We get 12, reattach x, keep sign, distribute. 3 times 1 is 3. On the right-hand side, I have a lonely variable here, and I'm going to stop, chop, chop. If I'm going too fast, go ahead and pause that video. Using the distributive property, we take that negative 2, we multiply by 3 is negative 6. We keep the sign. We distribute again. Negative 2 times negative 1 is positive 2. Reattach the variable x. So this is what we have left after we kill the parentheses. We have 12x plus 3 on the left-hand side, and we have negative 6 plus 2x on the right-hand side. All right, hand method. Get rid of the smallest variable parts. We're on this step right here. Smallest variable right now is 2x. So I'm going to subtract 2x, copy, paste. This will turn me right into that hand method, working left to right then. We have 12x, take away 2x is 10x's. If I haven't used it, drag it down. In the right-hand side, I have negative 6. Hand method. My job is to get rid of plus 3. I'm going to subtract 3, copy, paste. Working left to right then, I have 10x equals negative 6 minus 3. Be careful on that step. You can chop it. Or you might want to use your calculator as negative 9. Solving. Some of you might think you've done something wrong because you are going to get a negative decimal here. Divide by 10, copy, paste. The x value then is equal to negative 0.9 or 9/10. Substituting back into the equation. So we're going to substitute that back in for one of these. You either plug it back in here or plug it back in here or plug it into both. I'm going to plug it back into the bottom one. I'm going to substitute this answer down here, negative 9/10, in for x. Let's go ahead and take a look what happens then. So we end up with this negative 2 multiplied by 3 minus, watch your signs, negative 9/10. 3 minus negative 9/10. You might want to type that in your calculator. So we have negative 2 on the outside multiplied by 3 minus negative 9/10. When we substitute that in, that really turns into kind of a chop-chop scenario. And we end up with negative 7.8 as our y. Our y becomes that, negative 7.8. So here's our point of intersection then. Our x value is negative 9/10. And our y value is negative 7.8. So that is our point of intersection for those values, negative 9/10 and negative 7.8. So that's what's called point and intersection with equation graphing. I think you'll like it if you really like the hand method. You just really got to go slow. And a lot of times, answers don't come out as whole numbers, so be careful of that. Remember, the point of intersection is the same for both equations. And remember that you have to find the x, don't forget about the y. So when we say this first one, what we're really saying is that the y1 equation has to equal the y2 equation. But remember that when we do that, we drop off the y's and set the values equal to each other, and then we solve for x. Okay, so our homework for tonight, I'm expecting to see distributive property if necessary, combine like terms. I should see vertical lines, copy, paste. You need to plug back in to find the y value. There's kind of a whole bunch of stuff to do in our work today. Your homework is to do the rest of this page 21 and all of page 22. All the answers are on my website, so if you get stuck, you can go ahead and check that. I do have the work on the website as well, or at least it should be there at this point. So the rest of this page 21 and all of page 22 due tomorrow. Have a fabulous night, 8th grade.